All right, let's get started. So news from webperf-landia. So it's going to be a really tough act to follow. Impossible, I think. Only Colt can do what he does. So I'm going to give you some tips for some of the things we've been working on in the W3C webperf group and related topics about some of the techniques they can use to optimize your plundering around the web in particular. And there are 4 things that we're going to cover. Some of them are already available today. Some of them are coming. Some of them are actually still in the works. So we're looking for feedback, use cases, and all the rest. And that's where you guys come in. We're going to go in order of kind of these APIs. There's the best one by far is the bacon API for faster bacon delivery, and you'll see exactly what I mean. There's stuff like getting connection type, such that you can optimize your apps. You can figure out if users are not getting to your site, which is something that you can't actually do today. And then finally, we're going to talk about some of the work that I've been doing recently with resource hints. So let's start with the best one, blocking loot beacons. So a very common pattern on the web today is you want to track what happens when somebody clicks or when somebody performs an action. And in particular, that's important for things like, let's say somebody's clicking away from your site, or you're trying to just log some activity. So a user clicks on an activity, and you want to record the fact that they're going to a checkout or they want to buy something. The common way you do that today is, of course, because you're navigating away from the page is getting unloaded, you need to stop the page from unloading. You need to send a request to your analytics server. You need to wait for that to finish. If you're doing it right, and I hope at least you're setting a timeout, you're saying, well, I'll wait for 200 milliseconds or something like that, and then I will resume and actually let the navigation continue. And of course, that is a terrible performance pattern. It's an anti-pattern, in fact, because we're blocking the actual navigation from proceeding because we need to log the actual analytics. So that is why we have Beacon now. So this is a new thing that is now available in Firefox and Chrome. And using this API, you can actually post data to a URL asynchronously. So what this means is that you no longer have to wait, and you can get on with navigating to the new page, and the browser will take care of actually delivering the payload that you give it. And it's actually really nice because it's much more flexible than what you could do before, and it actually allows the browser to do better delivery. So we can do things like retries and other things on your behalf. So all of this is already handled. This is actually very similar if you've seen a ping. So this is an attribute that you can actually put on a link that says, for example, please navigate to the site. But when the user clicks on this thing, please also send a ping registering the fact that somebody has clicked on this. This is not supported across all browsers, but Chrome supports it, Safari supports it, and it actually is fairly well established on mobile. So for example, Google Search last year deployed this on all mobile search results, where before you were actually getting redirected to a redirect service, which would then send a 301. So that's an unnecessary redirect, and they needed that because they needed to register the fact that you've clicked on the link. This helped us improve search quality and all the rest. So nowadays, they don't do that. So instead, they use the ping attribute, which allows them to basically send 2 requests at once. One navigates to the actual destination, one logs the fact that a click has happened. So this helps you optimize performance. This works today. This is great, but it's limited in the sense that you can't actually post arbitrary data, right? You can encode some data in the URI itself, but that's fairly limited in terms of the amount of data you can push and what kind of data you can push in there. So in effect, Beacon is an improved version of a-ping. It's supported on both Firefox and Chrome today. And one nice thing is that it actually allows you to send up to 64 kilobytes of data. And this is arbitrary data. You can stuff a JSON payload or whatever other data type you want, and we will take care of just posting that data to the server. So that's available today, and you can use it. And best part, Google Analytics has actually just recently rolled out support. And you can actually enable this on Google Analytics. You do need to modify your code a little bit. You need to pass this additional flag that says use beacon true. So because this is still a new API, we have not enabled it by default. I'm hoping that in the future, we'll just make that the default, and you can opt out if you want to. And we'll use kind of detect the fact that maybe a particular browser doesn't support it. But this is by far a much better way to deliver beacons. So for example, if you're using Google Analytics and you're using things like click tracking, today they would actually tell you to kind of inject additional JavaScript code and all the rest and pause your navigations to log to analytics and all the rest. You can avoid all of that and get your bacon faster. So, and this is very important because this is how all of the like ads monetization and everything else works, right? Clicks matter. So one of the goals here was to make it simple, make it fast, and also improve the reliability of delivery of these beacons. So aping has actually had some bad rap in the past on the browsers that support it in terms of the actual delivery rate. It just hasn't been that reliable. With Beacon, we're actually taking kind of a clean slate approach and making sure that that is very well handled, and we're seeing very good results there. So definitely something that you want to check out. Use it today, available today, awesome. Next, we have forecasting network weather. So sometimes it's actually very useful to know what type of connection is a user currently on. For example, are they on a cellular connection or are they on Wi-Fi? Or, God forbid, maybe they're using Bluetooth tethering or Bluetooth to access the internet. And also, it's also useful to know more detailed data for things like, well, how fast is the link that they're on? So the fact that I told you that the user's on cellular is not very useful by itself because there's a lot of variety there, right? There's 2G, there's 3G, there's LTE and LTE Advanced and all these kinds of things. So we're now exposing two attributes, and downlink max is actually really, really fresh. This is something that we just recently added to the spec. So let's look at the actual logic here. So first of all, I guess let's talk about the use case. So this is a recent headline where Facebook is actually using bandwidth targeting to deliver a different experience. So in this particular case, this is for advertising. So they detect the fact that, hey, you happen to be in a slower connection, so it doesn't make sense for me to try and jam a video ad into this pipe because you're not going to even see it. Frankly, it's going to take you like 10 seconds to download it, right? So that's bad experience. So that's one use case of how you could use this sort of information. And note that we're not saying here that this is the actual download speed of the client. We're just saying this is the maximum potential speed that you could get, right? All we know is the last hop. Similarly, you can actually use a lot of this data to do analytics. So I've actually talked to a number of companies that are currently segmenting this data based on segmenting their conversion data on connection type, and they're finding different performance for things like, hey, we're getting a lot more conversions on 4G versus 3G and all the rest. And that is actually a good signal to tell you that, hey, there's maybe performance problems on 3G that we need to optimize to up the conversion rates and all the rest. So analytics, customizing what you deliver, what types of assets you deliver. Maybe you want to pick a lower res image or skip the video and other things like that. So downlink max is a new attribute that we're adding. And what it reports is the actual megabits per second of the last hop link. And this is very important. So what we're not telling you is like, what is the expected or the current bandwidth of the user? Because frankly, that is a very hard problem. It's a very transient thing, especially on cellular network, where these things kind of go up and down all the time. So instead, we're just saying, look, we know that the user is connected to an LTE network. That's all we know. And on LTE network, the maximum theoretical speed, right, regardless of what carrier you're signed up with, the maximum theoretical speed, like as written in the spec, happens to be 100 megabits per second. So when you query that value and it says 100 megabits per second, that's not to say that, like, great, I'm just gonna like dump the 4K video ad on the user, right? Like that's not what we're saying. We're just saying this is the potential, the maximum. And this, of course, becomes very useful for kind of the lower range of the pipe, where you start looking at 2G connections. Which are still very much prevalent. And believe it or not, you can also, like, I'm sure you've all seen it, we get bumped down to 2G even around here every once in a while, right? You go to a big event, you're on 2G. So this is where you can actually use this sort of logic to say, hey, I'm currently on 2G, I'm gonna fetch maybe a different set of assets, or I'm gonna do something else, optimize my experience for the user. Now, there's another important digression here. Carriers have pulled a fast one on us. Well, it's not just carriers, but they still pulled a fast one on us, right? We love to talk about megabits per second. Megabits and megabytes are very different things, right? So, sorry? 8 times different, exactly. So the next time you're hearing like, oh, I did a bandwidth test and my phone is really fast. I'm getting 10 megabits per second, right? Like and I'm downloading a 1 megabyte image. If you actually do the math, right? Let's say you have a 10 megabit per second connection, which is actually really, really good. That's about 1.2 megabytes per second. So if you had a 1 megabyte image, which is actually not crazy with our super awesome double retina something advanced super screens, that's double retina, exactly. HD, Retina HD, right? That's the word. It'll still take a second to download that image, right? And more likely, you're experiencing much slower speeds. So you have something like 2 or 3 megabits per second, and it will take 4 seconds, right? So this is an important digression, but I think it's something you need to keep in mind. Megabits and megabytes, don't confuse those things. And the spec actually reports it in megabits because that's how the industry kind of works. All right, so that's netinfo, and netinfo is available currently in Chrome and Firefox. We're currently implementing the max bandwidth stuff. So hopefully in the next stable release, that'll make it there. But today you can already query for type. Next one is what I'm calling sea monster detection. So there's actually a subtle problem that we have today on the web, which is if the user can't even reach your site. So for example, before we can log the fact that somebody has visited your site, right? First, we need to find the IP address, resolve the IP address, take the name and find the IP address of that. Then we need to perform the TCP handshake and all that other stuff, and then we can only send the HTTP request. So there's a bunch of steps in here that are basically invisible to us as web developers. And it's actually not uncommon for users to fail somewhere in there, right? So you send your UDP packet, and it gets lost, and you have no idea, because the visitor never made it to your site, right? The DNS timed out, maybe you're experiencing DNS problems, or your server's overloaded and the visitor can't even reach your site or establish the connection with your HTTP server. Those things are just go unreported unless you actually have some users kind of telling you that through a site channel saying like, hey, I can't resolve your DNS, and this is a problem. So for that, we actually have the navigation error logging API, which is currently in the works. There's no implementation of it yet, but I think we actually finally have the spec nailed down or very close to. So expect this to come soon. So how does this work? One way it could work is when the user comes to your site, you can actually call window.performance get navigation errors and just iterate through past errors. So if the user has had problems accessing your site, this would actually contain a full log of like, hey, I tried to open your site on Friday at 5 p.m. and I experienced a TCP something problem, right? And this is how long it took for this thing to time out. So of course, you can use that information to then log it into your backend and do all of the analytics that you want. But I think we can agree that that's kind of like, that's after the fact, that perhaps not as useful, right? Still nice to have, but not as useful. So what we also support is this method called enable navigation error reporting, which does live reporting. So whenever so first you have to come to the site, obviously, at least once, right? Where you would invoke this code and basically says, hey, this site would like to start tracking the error reporting, we'd like to register for error reporting moving forward. Next time, if the user experiences an issue, we will actually pull out that URL that you told us, and when the timeout happens, or when the connection fails, we will just beacon that information directly to that endpoint. And of course, this is the important part here, you should beacon to somewhere else, right? Because if I can't connect to your awesomething.com and I'm trying to beacon to awesomething.com, that's not gonna work. So you want to have like a third-party service or some other domain that is separate where you would send these reports. And this way you can actually get real-time reporting of like, hey, there's DNS timeouts, or maybe I'm getting blocked somewhere, or TCP connections are failing, and all the rest. So this is very, very cool, because today, in order to get this sort of data, you basically need to control the client and the actual site as well. And only the largest companies can do that today, and it's very hard. So this will be really awesome for just improving reliability. And then finally, we're getting to just faster navigations. So there's a bag of tricks here that we want to talk about. This is some data that I just pulled up from my own browsing session. So I'll show you guys some examples later, but if you go to Chrome histogram, anybody been to Chrome histogram before? Open a new tab and just go to Chrome histogram. It has a very long page of like all the different metrics of everything that happens in your system. And it's just histograms of like everything. Just type in TCP and you'll get like 15 charts. So what I looked up in there is like, what is my median DNS resolution time? What is my median TCP handshake time? What is my median TLS handshake time? And all the rest. And by the way, this is based on like 10,000 samples, and this is based on a last day of me just using my computer on this Wi-Fi, right? So you'd expect this Wi-Fi to be pretty fast. We do a pretty good job of it at Google. But nonetheless, you can see that things like DNS handshakes, TCP handshakes, and all the rest or DNS lookups rather, take quite a bit of time, 60 milliseconds, 35 milliseconds. If I add all of this up, for a typical page, a median page, it takes about 200 milliseconds for me just to establish, kind of perform all the ceremony before I can actually even send the HTTP request. If you substitute numbers for things like 3G or 4G, this very quickly adds up to 1 second of latency, right? So there's a lot of latency that is just spent on the initial setup and the ceremony. And browsers do a lot of stuff to try and hide this. We have things like, hey, let's try and pre-resolve all the links. So when we open a page and there's a bunch of links, we just like, let's just look up all the DNS names, or at least some of the DNS names, such that when you click on that link, we don't have to wait. Let's pre-connect. So before you even click on a link, or as you start to hover towards the link, we'll just say like, hey, it looks like you're going there. Let's start pre-connect, right? Because between the time that you actually get to the link and click, that's a couple of hundred milliseconds. And a couple of hundred milliseconds counts, right? Because by that time, we could have established the connection, and we can send the HTTP request immediately. So that's pretty sweet. And then there's things like prefetch and pre-render, where we can actually just say, like, look, I think this user is likely heading in that direction or into that page next. So let's prefetch the resource, or let's just pre-render the entire page. We'll just like literally create a hidden tab in your browser. We'll pre-render the page, and when you actually say like, yes, I want to go there, we'll just swap it out. And it loads instantly, but we're just really swapping kind of behind the scenes the actual rendering, the renderer. So these are tricks that are available across most of the browsers today. And in Chrome, you can actually inspect all of this stuff. If you go to something like Chrome DNS, so once again, open a new tab, Chrome predictors, and Chrome histograms. Between these three, you can actually see all of the different things that we're kind of doing under the hood and trying to predict and all the rest. So Chrome actually learns quite a bit about your browsing patterns. So over time, as you use it more and more, we actually observe things like, hey, what are the first 10 tabs that you open in the morning when you open Chrome? We'll remember that, and next time you open it, we'll just pre-connect to all of those sites immediately. So, yes, you're going to check the news, you're going to open Gmail and something else. These small tricks do a lot to improve user experience. And the interesting observation here is that the browser does a pretty good job of this, but site developers, you guys, have a lot of knowledge about your own applications, right? If the user is expanding, let's say we're looking at a sports app, right, or a sports section, and if you know that the user is always navigates to the NBA section and then clicks on whatever team, right? Like that's just what they do each morning. Or whenever a user expands a particular section, then they go to something else, right? You know these things that the browser doesn't. And what we really need to do is provide you the same sort of primitives, access to the same primitives, so you can hint the browser to say like, hey, I think the user's gonna do this next. So start doing your stuff. So that's what these resource hints are, right? We have three: pre-connect, preload, and pre-render. So the quick anatomy of this thing is basically this is a hint. It's a link element where you say, you put a resource name. We'll talk about the rel, which is the pre-connect, preload, or pre-rendered. That's the type of a hint. There is the as, which describes the type of the asset that we're talking about. So this is basically like, I want you to fetch this as if it was a style sheet, or as if it's an image or something else. So this just allows us to prioritize the fetches more better in the browser. Then there's the actual link, and of course, media queries. So you can say, look, this hint is only relevant if I'm on mobile, right? And my screen is thus big, or it's only relevant for high DPI screens and all the rest. So that's as expected. Oh, and probability, so we'll talk about that. So let's look at the simplest one and the first one, pre-connect. It basically just says, look, there's a lot of latency that is spent just doing the DNS, the TCP, and the TLS, because increasingly we need to just secure all the things, right? So what we can do here is we can say, look, I think I'm going to be fetching resources from the server. I'm not yet sure what resources exactly I'm going to fetch. So for example, you have some dynamic thing that you need to fetch. Like I know I'm going to have to connect to an ad server and request some ads. I'm just not sure what they are yet. So just start doing that now. And by the time you're done, I'll probably know the actual URL and everything will be much better. But then you can also say, look, sometimes I'm not quite sure. Like I may need to connect to this thing, but maybe not. And that's why we have probability. So probability allows you to express some sort of notion of like, I may or may not need this thing. And you'll see why this becomes more relevant for some of the other hints. But this is one of those things where you can be anticipating user behavior, right? You could say, well, if the user expands the NBA section, I will need to connect to these 5 things to fetch these other images. And I think the probability of the user actually doing that is about 0.75, something like that, right? So if you tell us that the probability is 1, it basically means it's a required hint and the user agent must execute it, whereas everything else is kind of up for grabs, right? The observation here is that these are speculative optimizations that could, in fact, request extra resources which may go unused, right? So if you're really, really aggressive with all of your prefetching and all the rest, you're going to fetch a lot of data that you never use. That's also not good, right? Because you've consumed users' data plan, battery, and all the rest. So as an example, let's take 2 hints, right? We have a pre-connect with 1.0 and pre-connect with 0.4. Depending on how the user agent is currently, or how the device is doing currently, it will say, great, look, I've got full battery, I happen to be on Wi-Fi, I got a ton of resources, I'm just gonna follow this whole thing, right? And in fact, for 1.0, that's pretty much guaranteed. But for a low probability hint, something like 0.4, like you may or may not use this, and I happen to be running low on battery, you know, like maybe I'll skip the hint entirely, but for this case, maybe I'll just do the DNS pre-connect, right? Or the pre-resolve, rather. So the user agent reserves the right to kind of shift some of the work and figure out what is the optimal strategy to kind of improve the user experience here. Next, we get to preload. So this is kind of interesting. This is basically a declarative way of saying, I need this resource. So pre-connect was just a way for you to say, I need to connect to that server. And that's important because it just takes a long time. For preload, this is basically like, think of this as XHR, kind of, but in a declarative way. And what you're saying here is, look, I will need this critical CSS file. Please fetch it as if it's a style sheet. I will definitely need it. Only fetch it if the screen matches this media query, or if this media query is matched, rather. But the difference here between fetching this as a regular style sheet is that it's actually not processed. This is just downloading, right? Like, please just download this. Don't parse the CSS. Don't execute it. Don't apply it to the current page. I will tell you later when I want this to be applied. This is really cool because today, whenever you include a link rel style sheet, we actually block rendering on that because that's just how CSS works. So now you can actually decouple these 2 things and say, like, download this now, and later I will inject it into my DOM and all the rest, and you can apply it and do all the other things that you need to do. So this is really, really useful, and it will solve, I think, a lot of problems for us. And then finally, we have pre-render. So preload is something that you would use to fetch resources declaratively for the current page, things like critical assets, additional assets, and all the rest. And pre-render is something that you can use for the next page, where you can say, look, I think the user is heading in that direction next, and on that next page, I will need these CSS files, these images. Maybe it's a big product image that you want to prefetch, or pre-render, I guess, and such that it's displayed very, very quickly. And perhaps the biggest difference here is when the user starts navigating towards the new destination, we don't cancel those requests. So today, if you think about it, if you initiate a bunch of XHR requests, and then the user clicks away, we will actually cancel all of those, right? That's just how the process works, because we don't want to persist those requests because, well, you're navigating away from the page. So why would we like cancel all the things and let's move on to the next page? So pre-render actually allows us to, this is a hint to say, like, I think I will need this on the next rendered page, so please don't cancel these things and let them continue. And then the next page can make use of them. So this way you can actually use a similar strategy as I described before. As the user's heading towards that link, you could say, like, I know what they're heading. I know where they're heading. I will need these 5 resources. So start fetching those now. And then the next page can be rendered much faster. So here's kind of a quick overview of how this actually works and where you would use it, right? We have fetch start here at the top. This is where we just start fetching the page. And you can inject a bunch of hints right at the beginning of the page to say, look, I will need to pre-connect to these servers. I will need to pre-fetch these resources. Do all that for me. So this is a way for you to help optimize the initial render. Once the page is rendered, you have all of your regular tools. You have the XHR, the images, the scripts, and all the rest. None of that has changed. Everything's the same. Then finally, there's another transition here, which is the user is navigating away or towards a new destination. And you can say, look, this is great. This is where you use pre-render, because you inject the pre-render hints on the current page, but they will be used on the next page, right? So it's that's the only distinction, really. the important distinction between preload and pre-render. So this is a working living doc. There's a lot of examples. The spec is something that we've been working on in the webperf group for a couple of months now. Please check it out on GitHub. There's a lot of examples in there. I would love to get your feedback in terms of what are the other use cases that perhaps are missing, that we're not covering, and all the rest. So take a read through. I tried to keep put as many examples in there as I could. And this is a quick summary. If you're not familiar with these APIs, just follow these links. I'll share the slides, and you don't need to copy that because you can actually find the slides at Pirate Perf and Perf Matters. All right, thank you.